We have studied about the embedded system and its functions, characteristics, etc. Embedded system is the combination of software and hardware, and it is the system designed to perform a particular task, and task has to be completed in a given time. Embedded devices cannot operate without the embedded software. Embedded software development requires an even wider range of tools like editors, compilers, debuggers, profilers, linkers, etc. to facilitate greater productivity. This chart indicates the embedded software compilation process. High-level language is going to be converted into assembly language and into machine-level language. This machine-level language can be understood by the process. High-level language is English-like sentences that user can understand the high-level language. Machine can understand the machine-level language. So to convert all the steps to machine-level language, like the form of ones and zeros, this compilation will be useful. So the compilation is a software which is used to convert one language to another language. So with the help of the compiler, the high-level language is going to be compiled and it is converting into assembly language. So after that, the assembly language, it is going to done assemble. So whatever the assemble, that converted into assemble, that object value is going to be linked. After linking, we will get the executable file. So that executable file is going to be loaded in the chip. So once it is loaded in the chip, then the chip is going to perform the operation. So compilation is nothing but the combination of translation and optimization. As we have mentioned, compiler is used for converting the source code from a high-level programming language to a low-level programming language. It converts the code written in high-level programming language into assembly or machine code. The main reason for conversion is to develop an executable program. Compiler have the front end and the back end. The front end will check whether programming is correctly written in terms of programming language, syntax and semantics. Back end is responsible for translating the source code into assembly code. These are the operations performed by compiler: code generation, code optimization, parsing, syntax direct translation, pre-processing. Out of this, analysis of code and optimization and code generation is done by the back end of the compiler. Another one tool is cross compiler. If a program compiled is run on a computer having different operating system and hardware configuration than the computer system on which a compiler compiled the program, that compiler is known as a cross compiler. Decompiler is a tool used for translating a program from a low-level language to high-level language is called a decompiler. It is used for conversion of assembly or machine code to high-level programming language. Assembler. Assembler is embedded system tool used for translating a computer instruction written in assembly language into a pattern of bits which is used by the computer processor for performing its basic operations. Assembler creates an object code by translating assembly language instruction into set of mnemonics for representing each low-level machine operation. Assembler is also a type of compiler. Difference between assembler and compiler is that compiler converts source code into assembly code and the assembler converts the assembly code into object code. Object must have some resources. Object file might has some unresolved symbols. Another one is linker. Linker is a computer program that links and merges various object files together in order to make an executable file. All these files might have been compiled by separate assemblers. The major task of a linker is to search and locate referenced module or routines in a program and to determine the memory location where these codes will be loaded, making the program instruction to have absolute references. This chart will indicate the operation of a linker. Different objective files are linked to make an executable file. Another one tool is loader. Loader is a program which accepts the input as linked modules and loads them into main memory for execution by the compiler. Loader loads or copies program from secondary storage to main memory of execution. These are the functions of a loader. It allocates space in memory for the program, linking simple resolution between object modules, adjust address dependent location of address constants, that is, assign load address to different parts of a program, and store machines instructions and data into memory. Debugger is another tool. A debugger or debugging tool is a computer program that used to test and debug other programs. The code to be examined might alternatively be running on an instruction set simulator. When the program crashes, the debugger shows the actual position in the original code if it is a source level debugger. If it is a low level debugger or a machine language debugger, it shows that line in the program. Basically, there are two common methods used for debugging. These are single step control and breakpoint technique. In single step control, each step of the program is executed and tested. The debugger allows user to examine the contents of registers and memory locations after each step of execution. In lengthy programs, debugging is done by breakpoint technique. In breakpoint technique, a breakpoint is introduced at a desired point in the program using software instruction. Profiler is another tool. It is a software program that gathers information about a program during execution. Profiling is achieved by instrumenting either the program source code or its binary executable form using a tool called a profiler. Profilers may use a number of different techniques such as event-based, statistical, instrumented, and simulations methods. Profilers use a wide variety of techniques to collect data, including hardware interrupters, code instruction set simulations, operating system hooks, and performance counters. Profilers are used in the performance engineering process. It is used to know which areas of code to optimize speed and memory. Profilers may show time elapsed in each function and its descendants. Another kind of embedded system tool is test converge tools. Test converge tools provide statistics and detailed information about which parts of an application program have been executed. This information is invaluable to software terms to help determine the readiness of software for actual use. This information is invaluable to software terms to help determine the readiness of software for actual use. The types of converge information collected are branch converge and code or test converge. Branch converge, it is the subsums statement converge. Code or test converge measures used to describe the degree to which the source code of a program is tested by a particular test suite. A program with a high code converge measured as a percentage has had more of its source code executed during testing, which suggests it has a lower chance of containing undetected software bugs compared to a program with low-code converge. These are the typical features of test converge tools. It is not dependent on any particular compiler or object formats. It works with tens of thousands files. Very low probe overhead, that is one or two machine instructions per executed probe. It can accumulate converged data from multiple execution runs. It produces converge report by application, subsystem, and file. Test converge delta computation and display to enable test case minimization. It can operate with custom or embedded application execution environments, and it consistent style and across different languages. So these are the important embedded system tools. Thank you.